Okay, 899 orderly queue. A string S of lowercase letters is given. Then we may make any number of moves. In each move, we choose one of the first K letters starting from the left, we move it and place it at the end of the string. Return the lexicographically smallest string that we could have after any number of moves. Okay. And then we have a couple of examples. N is 1,000 and S consists of lowercase letters only. Okay. Uh, let's see. After the first move, A goes to the. We move stuff to the back. So after one move, we do this K. So we could. Okay, so we actually have unlimited number of moves, but we can only use the first K letters. Or we can bring some first K letters. So if K is 1, we can only do C to the back, and then B to the back, and then you get ACB. Okay. With K is equal to 3, first we move B to the back, and then C to the back. Okay. Kind of think. I think the kind of like my first instinct is to think about the greedy solution and whether it works or not. I think in general, I don't know if I would think that the greedy would work. Like some sort of sorting things, but and the number of greedy things you can maybe do, which makes it not necessarily one. But I'm also trying to think if there's a way I could that's cleaner than greedy. I think one greedy algorithm would be just to take yeah, there may be so many edge cases though. Because I think one maybe greedy algorithm that I would think off the bat is just to take the earliest letter, like starting from or the earliest in the alphabet letter, and then move it to the back. But then, what do you have like? Which one in this case? Which one will you move to the back from the first? Say, I don't know. Let's say you can move anything, and you have choice between these two B's. And does it matter? Well, it matters if no, if you have unlimited amount of moves, then maybe it doesn't matter. Then you get to both of them. But well, two possible outcomes. Let's say the answer, let's say you could, K is 6, so you move to first 6 in this case. Then two possible things that you get A, B, C, B, or B, and then you move to second one. So you move this one. Clearly, this is. Well, if you have 6, then actually you could actually move these back. So you get that. So that's strictly better. And, well, even in this case, you can move the C's back. Maybe that's not a good counterexample. I think for this problem, I'm not convinced that the greedy works, even though I don't have like the example I put is kind of not necessarily true. But I could see a scenario that's similar to it comes out to be true, because you can imagine having like more A's and then as a get buffer, then like you have something like this versus Now let's say you do greedy and then versus, I guess even the other way is fine, but maybe I'll just try to do greedy. And this is going to be a mess. Possibly. I thought this was supposed to be. Well, I think that I'm trying to think about observations. I think the first observation on top of what we talked about is that if you have a move that makes it better, then you should make it. I think that's fair, right? Right. It doesn't, and this is the non-decision part. I mean, any move in general will give you a more optimal answer. And the question is, after that is, well, let's say you can move between two letters and they both make things better. Can we just do a naive comparison? Like, would that greedy work? Like, you always want to move the letters in the beginning or near the beginning of the alphabet. Like, you always want to move the B's before C's because later on, because in a similar, because no matter what K is, if you move the C before B, then the C will appear before B, and either, well, one, you could fix it later because the K is big enough, or two, if the K is too small, then you already have a suboptimal answer. So I think that's kind of the strategy I might think about, and then, but for me, it's just it takes a lot of effort for me to prove. Well, it takes a lot of effort to prove that a greedy solution is correct in general, but also even for me as part of this to kind of prove to me that a greedy solution is correct. But I think maybe that's okay. All right, let me type it up and then kind of see if I can spot any spot any kind of edge cases that I had not considered. Yeah. Okay. Okay, now I have to think about how I want to do the coding part. Because potentially we can do something weird. Yeah, okay. I think the other thing is that if we have, say, let's say A, B, B, C, B, we actually want to move to, and then like a bunch of stuff, say. Let's just say they're all A's anyway, and you only have 5, and you actually want to, move to B first, and then the second B, the first B, the second B, and then the C. Even though I guess this has to be A's, otherwise they get moved to at some point. So yeah, so you don't move to the first character, you get the earliest character that's in the thing. Okay. something like that. And so, oh yeah, so in terms of complexity, because you can, because is that true? Yeah, so each, I think there's another edge case I have to consider, but which I didn't. I mean, it's something that I think I was just innate with me, but I didn't think about articulating. Is that well, two things. One is that each character should only move to the back at most once, because if you need to move it back twice, that means there's some substructure optimality is incorrect, uh, because let's say even in this case, right? If you get to a point where like let's say we move a bunch back and um, there's no reason for you to want to move the piece back. Yeah, because if that's the case, then you can only get a worse result, right? Like let's say we move the first P, then you only get a worse result because they had B before. So you should only have, you should, yeah, you should only move to each. You should only move each. What do we call it? Each character once. So that actually gives you an n square algorithm, but you have to do the moving kind of efficiently, right? Well, no. Well, why did I say n square? So this, what I mean is actually this loop can only execute n times, and then so if whatever operation we're doing takes off n, then it'll be n square. Okay. So I think that's the allowance we can have for 1,000. N square should be okay. N to the third maybe a little high though, so but I can't. I think the other thing we kind of didn't articulate but thought about kind of is that if the first X letters are already done, you actually never need to move them again, because like if you have A's in the front, sure, you never need to move the A's. But even in my other example, where at some point you get to AA, BB, C, and then etc., you actually yeah, if there's no more A's, and by the time you get here, that means there's no more A's, because if one of these dashes is an A, then it will get buffered to the front and it will just be here, right? So in that case, you actually never look at the first X letter. Yeah, okay. So I think that's the kind of, because you could say that the first X characters are done. Okay, I think maybe I can convince myself that the greedy works for this one. Just have to implement it in a relatively efficient way. How to do this? Oh, maybe I actually don't want this. Maybe that's why I want my API to be. Let me turn this. Something like that. Okay. Okay. So I'm just trying to think about how to precisely write down in code what we talked about, the rules. I think we could probably break into a few chunks. We just get the lowest. So I think the first thing we can do is calculate the number of inversions in the thing. If the inversions is non-zero, then we're not done in the first k. No, in the entire thing. But well, two things. If okay, so we have to count the number of inversions of something that's after k to be in k. So the two numbers, if the inversions of, well, first of all, if there are inversions in S in the first k characters, that means you're not done. Also, if you have inversion, if the first k characters have no inversions, but one of the characters that's after the kth letter is before one of the characters in the first k or k letters, then it's also not done because you can move that to the front. Okay, let's do that for now. Actually, also maybe I'll just go. Maybe I use helpers instead. I have to change this. That's fine. I've double checked. So this is. I could do smart. I have to be smarter than that. Because so the naive way to do the inversion would be to just do like a for I for j loop, but we can probably actually do better than that by just going through the loop once by taking the max. Yeah, we can taking the max of the first kth letter, first k letters, and then the max or the min of the second half. Okay. Because we don't need all the inversions or even the number of inversions. We just need to know whether that number is 1 or not, right? So there's an inversion in the first. Okay, so the two examples. One is if inversions first k, then return false, right? Because that means we're not done. In this case, you could do it in linear time by what you call it? By looking at two adjacent characters, right? Actually, And the second function is it's a really wordy thing, but maybe it isn't even a good enough name, but I'll replace it later if necessary. Well, actually, we assume that this is true. Oh. We assume this is false, rather. That means the first K letters is already sorted. So that means the max letter, it'll be in the last character, or the kth character, actually. Okay. Just to make this slightly clear for me in terms of inversion. Okay, if that's the case. Otherwise, I guess maybe it's done. We might come back to it. But otherwise, we move, which now we how do we choose the letter? Okay. Oh yeah, because we can only move. We can move in the first K, so we actually choose the letter that's closest to A, but isn't in the front. Okay. Okay. Just go through it then. How do I consider this a candidate? Is a candidate if so this is a candidate if it's greater than the next one. That's not all. So if it's next bigger than the character afterwards, then yeah, you cancel it. Otherwise, there's maybe a different way of expressing this. Well, this is where the inversion is. This is definitely a candidate. But how do you get the first B in this? No, that's not true. This isn't quite right, because if you have something like PPPPPA, this will only add this one and not the first one. Okay. I think maybe the alternate way of doing this is we pick the min on the first k characters, and that is the safe one. There's still going to be edge cases where that's not true, so it's like a weird, almost like an insertion sort, but backwards, or a selection sort rather. Yeah, selection sort, but backwards. Maybe I should go through this, and then now I choose. There might be an off by one, but I think now we add these candidates, and then now in the exponent. From all those, we choose the first one that matches the smallest one of these. Actually, then I guess we don't need candidates. Just need a candidate. Maybe is that a good default value? Okay. Now we look at the first K. Actually, maybe this default should be S sub K minus 1, so that if we don't choose anyone else, unless it's perfectly equal to the last one. Oh, geez, maybe. Because that would be the one that you move. Otherwise, the invariant is that there's something else that's moving up that's in the second half because it's not done. Okay. Now we want to move this answer. Okay. Now we need from 0 to something like this, though it's off by 1, I think. And I have to check some stuff. Okay. Also have to, I create a lot of strings in this, so I have to kind of go back and fix it. I just want to see if this works. Right. Have a typo? Yeah, okay. Oh, yeah. Oh, no. Well, it probably just means that this is an infinite loop, but let's see. Doesn't show us the beginning of what S's are. Okay, so we subtracted too much, though. This should be, there's no inversion, so we, in theory, this should return done. Oh, well, also, sorry. Let's see if that returns. I know it's not right, but at least it returns. Okay. What's it? This has to be true, so, okay. Perfect. Okay. Thanks to, no. Why is S plus 1? I mean, I plus 1. Oh, man. That's silly. Okay. Yeah. That answer is correct, but I'm still not confident about it. Didn't I have, oh. Okay. What's my type? Stop printing. Oh no, these are just. Oh. Wait, I figure I have an off by one somewhere, but let's at least see if the answers are correct. K should be less than S. Oh, let's do this one at a time. I got lazy. Maybe that my choice as well. Okay, and I E in some letters. Why is this standing out? Oh, because I still have this. When I is used, zero logic is maybe wrong. Now, let's get Kennedy. Like, Oh, so this is just wrong. Okay. It's kind of hard to define what I was trying to figure out precisely, with at least still in linear time, because we actually want. be a candidate? Why are A's candidates? Oh, because that's just a default because of this thing. Okay, fine. It's just this. Let's just see what happens here, but we don't modify K in any way. So. I think it's just that as a result, we actually return nothing, and then therefore this cracks out. So, but that just means that candidate. And after one iteration, we never consider the last one. Basically, if there's still an inversion, otherwise we choose something else. Does that count? Yeah. How do I feel about that? I mean, it's kind of right. Yeah. This is probably not right. You actually want the biggest letter in. We'll have to figure it out. But let's figure out this off by one thing first. C, A, B, C. Makes sense. That's the A. Sorry, fine, it's just debugging some edge off by one cases. Okay. This is probably still not right per se. We want to do this only if this is larger than some other number in the second half. Okay. Otherwise, I guess we're done, but that seems weird. That probably seems weird, so I don't know. With that definition, we're not done, but maybe we just kind of have weird cases because I chopped off plus one. Okay. See, that's not good. How do I phrase it? There's inversions on the second half. How can we guarantee that? Maybe, man, this would suck if greedy is not the right way. Good. Maybe I could think about another way I could think about this is maybe do them in reverse. I think greedy maybe is a little weird. Let me think about maybe there are only fewer cases. Because, well, for k equals 1, this is just a rotation of it, right? Like, because you can only move the first step back, so it's just like the smallest rotation. And then for k not equals to 1, maybe greedy doesn't work. Can we? I mean, then now you have like a rotation of this, but is that, can we do better? Yeah. I think that's the part that I was always worried about greedy in the beginning, which is that, let's say now you have AA, BCB, maybe even something slightly more complicated, but like that. Well, if you do greedy, this is, and k is equal to 3, maybe that's already done, and then you can do better, but the actual best answer is AA, BB, BBC. But my question here is whether you can lose these A's to the back and then just move them later. Yeah, I guess so, because for k, let's say 2, now you can choose the 2 and then so, yeah, okay, because I think actually even though there are A's in the front, if k is more than 1, you can actually kind of like, well, you move the first 5, and then now you sort, well, I guess you just, yeah, because on one iteration, let's say you have something like this, well, actually this is a bad example, but let's just say something like this, after one I don't know, cycle of it, you could actually think of them as two, if you have infinite time and you're not trying to simulate, the answer is that so you can keep the first 5 and buffer by putting them in the back like a circular array, and then now you swap the letters that are not in order. So now you have B, B, C, C, B, B, C, something like that. Is that true? you have like a rolling window type thing of these two, then these two, you take the B, so now CC, so you have to take a C, but then now you get a B actually, and then you have two B's and C, so something like that. So that already takes another N, but you could do it again by ignoring the first, in this case 7 now letters, and then because you pop them immediately to the back, so by ignore I actually mean, oops, I mean like getting to here, and then now you get the first B, and then the second B, and then CC. You just put them in the back. I think my question here, I'm missing, it's about the same, I'm missing a C. I think my thing is trying to figure out like, I guess I'm, no, because I messed up. It almost seems like you could always sort it, maybe, if K is not 1. But is that true? I'm trying to figure what kind of time. Because if you have infinite amount of moves, I mean, maybe I was optimizing for the number of moves. But if you have infinite amount of moves, and this with this inversion, you could always get it out by just like at the worst case scenario. What is the worst case scenario? Worst case scenario, well, that's not the worst case scenario. Worst case scenario is, I guess, something totally inverted like CPA, which actually maybe is the example, but like CCCCPA, something like that. In this example, we can always, so every full iteration, we make it closer to optimal. Is that right? This is what it equals, at least. But then after one cycle, you can, if K is 2, at least these, at this point, it would swap. So maybe something like, well, not even just these two, because it's like a rolling window. So you have something like this. And then something like that. So, so actually that should prove that you're able to sort anything, because I think this is just a bubble sort, because you always find, I mean, it's like a bubble E sort with some stuff maybe in parallel, I don't know. Because you can maybe, well, for K equals 2, then it's a bubble sort. For K equals 3, then you can move 2 letters at the same time in one iteration. But that just makes it faster. So in that case, you should always be able to sort. Yeah, okay, I wrote a lot of stuff. Hoping that was good. And this is why I'm always skeptical when it comes to greedy algorithms. But well, I think that's. I'm not super. To be honest, I'm not 100% convinced, but. I mean, I think but I would say my skepticism is not necessarily. Yeah. Yeah, I think my skepticism is that maybe I'm just not as familiar with kind of these kind of the like the intricacies of the sorting type things, and not because I don't believe in it. But yeah, K is equal to N is selection sort. Oh yeah. That's true. Yeah, and you sort the biggest letter in from the to the bottom to the N. Yeah, I mean I agree with that assessment as well. And obviously, if K is equal to N, then you keep on doing it, which is what you're saying, I guess, which is N squared. But okay, I think I'm kind of convinced. And K equals 1 is the obvious case. In between, and with K equals 2 being bubble sort, and I guess it's just like you said, some kind of I've seen that problem before where there's it's like bubble sort, but you can only sort something K distance away or something like that. Not this K, but and the complexity ends up being still the same. So anyway, we got some But yeah, good observation now too. Thank you. Okay, cool. So I'm just doing rotations. This should work for s equals 1. Let me just test the example case real quick. And the other ones are nonsensical, but well, actually, I don't know. I guess this is just oh, well, this is wrong, but let's see if this is yeah. Okay. Gotta be better with Python. But yeah, let's see if this is true. I think I'm using C syntax here. Thanks. I definitely need to well, just like practice this Python stuff. Okay. I mean, if what we believe is true then. But this also, is this the case? Probably have some up I want to use though. Oh, wait, that's because I'm returning the wrong thing. I am really bad at this. Also, it is kind of annoying in that like we spent about 45 minutes to write about 10 lines of code. That took too long, but okay. Well, how do I feel about this? Yeah. I think, I mean, as a problem solver, this is a cube problem. Yeah, right. I mean, as a problem solver, this is a cube problem, and it's something that I guess I don't know. I want to think about how I could improve on this next time I solve a similar problem without necessary, just by memorization, which is fine, kind of. But I think that maybe if like maybe something I could do is to review different sorting algorithms and how kind of to prove them one way or the other. I don't know if that helps enough or at all. Trying to think how to like how one-off is this and so forth, isn't it? As a problem solver. I mean, I think the k minus equals 1 is probably obvious. I could have special case that, but I don't know how how to kind of get to it. I think I don't know. I also don't know like how how repeatable what I'm doing now is, right? Because I think some days, some connections are just a little bit harder, but and sorting is also one of those things that like I feel like like yeah like I guess like you want to be able to prove these things mathematically, so similar to mathematics, like in a rigorous manner, so that you can convince yourself. Because I think like it's one of those things where like it's hard to prove like without a proof. Like if you're just doing like a billion counterexamples, then I don't know, right? Like, well, in this case, you wouldn't be able to find any, and if I was like, let's say, about doing competitive programming or programming contest type things, maybe that hunch is good enough for me to submit. But I even then, as as this video shows, that took like half an hour just to kind of think through greedy. But I should have been thinking about sorting. I think one thing that I could have noticed maybe is that like the infinite number of moves. And I don't know if, yeah, it's tough. Maybe I just have to hope that this type of problem doesn't come. I mean, obviously now I know how to solve this particular problem, but if I see something similar but not really, but how, it's nice to kind of figure out how to get to it. And I'm just thinking about problem solving. For an interview, I would imagine that like the interviewer would, if nothing else, I think a responsible interviewer would ask you why you come to this conclusion. And to be honest, like as you kind of see, like I could work through some examples to kind of show that it's like a bubble sort in the k equals 2, and for k equals n is a selection sort. I could kind of show that. I don't know. It's not as a rigorous proof as it's not going to be a rigorous proof at all. And there's no like, I'm just going to type up the code and and see if it's right. Where like that probably won't find an interview. So I don't know how to kind of improve my performance that way, other than maybe more studying on sorting. But I don't even know where I would start on that per se. But that's kind of, I don't know, I'm struggling a little bit to see how I can kind of learn from this. I think sometimes I kind of see where the mistakes are, but in this case, I mean, one thing I guess I could do better about that is I did spend half an hour or so coding up the greedy solution when I could not prove it necessarily. Though it did, going through it did drive my understanding of the problem, but maybe there are more efficient ways to go about it. I don't know. I mean, maybe these things with, I mean, I think I mentioned, I don't have it up anymore, but I was playing with the idea of inversions and stuff like that. So that is already a concept that's related to sorting, and maybe I should have, I don't know how, like looking back, like as a postmortem, kind of like how I can make that jump from, okay, there's some sort of sorting E thing versus, oh yeah, for K, greater than or equal to 2, we just sorted, right? So, I don't know. Maybe it's something that I have to study offline and kind of really think about it. As an interviewer, I would probably never ask this question, to be frank, just because some of it is just like too gotcha-y, right? Like we have seen this before, obviously, maybe from Leetcode or whatever. Like this is such a useless question in that regards. And in the sense that like we've seen it before, then you would just type up not even 10 lines of code. And the way I even wrote this was a little wordy. But like we could do something 8 lines of code, then it's not the type of question that I ask for a 40-minute interview or whatever it is that we have. And yeah, so that's mostly the reason why I wouldn't ask it. I think the difficulty, like it's one of those problems where it's binary, right? Like I tend to favor questions where like you could solve maybe just say 2 or 3 parts. Maybe you could solve part 1 or part 2, and I give you a hint on the part 3, or even something in between and so forth. And here there really isn't any hint or progression that a person can kind of work on. So, but yeah, for those reasons, I would not ask this on the interview. But I don't know if I would expect this on a reasonable interview. Like, I mean, on any interview, anyone can ask anything, and because I definitely had my, share of brain teaser type interview questions asked on me. So I don't know how much I can prepare for this. But I guess now it's in the back of my mind, so it's a good that I kind of looked into this. But